Hello everyone, you're welcome to All Maths with Feyi. In today's video, I'll be teaching you how to convert fractional numbers from any given base to base 10. Fractional number is also called decimal number. Some refer to it as decimal number when you have a number written like point something, 24.31, a base 5 number to base 10. Now, a very important prerequisite to this knowledge is the basic knowledge of indices, addition and subtraction of decimal numbers, multiplication of fraction and decimal numbers. You wonder why I do list prerequisite knowledge in my videos? Because I understand the theory of mathematics. Mathematics is like a ladder. Most times when you have challenge with any topic in mathematics, a challenge is not that topic, it's a prerequisite knowledge upon which the new topic you're learning is lying on. So when you have challenge with that new topic, most times it's actually the prerequisite, so that you may have to revisit. So let's dive into this example. So today we are converting 24.31, a base 5 number, to base 10, right? I have a video where I've explained how to convert whole numbers, that is numbers that have no points, from any given base to base 10. I'm going to drop the link to that particular video. Peradventure you have not seen it, I will advise you pause this very one and see that video first. Nevertheless, you may also still be able to pick it from here, because we're going to mention it here, only that we're not going to emphasize on it. So one of the very steps you do when you're converting any number, be it whole number or fractional number, from any given base to base 10, is to identify the digits in the number you are converting. As we have it here, we are converting 24.31. So to make it clearer to you, let's first deal with the whole number part. We have 24, 2, and 4. These are the whole number parts. As I've said earlier in that video, you're multiplying those digits by the initial base you're coming from, in this case by 5. So you're multiplying 2 by 5. Adding it together, you're multiplying 4 by 5. Now, not just 5, but 5 raised to the power of the position of that digit. Notice the whole number part we are addressing now. We are still coming to the decimal part. So the position, you usually start from the right, you move towards the left, starting with 0. So the position of 4 here, that's 5 raised to the power of 0, 5 raised to the power of 1. If you have more numbers, you continue 0, 1, 2, 3, and continue that way till you get to the very first number. Now that's for the whole number parts. Now let's come to the decimal part. Okay, points. So we have treated 2, 4. That's 24. 2, 4. Then we have points. Okay. Of course, we're going to be adding everything together. This for the decimal parts, we have 3 and 1. So the same thing also applies here. 3 multiplied by 5. Adding it together, 1 will also be multiplied by 5. So we multiply each of these by 5. Now this is where the difference is between the fractional part and the whole number part. For the fractional part, for the whole number part, we started with 0, we move this direction, right? 1, and you continue. Now for the decimal part, after 0, the next integer you have, negative integer, is what? -1, -2. It's as simple as that. Anyone after the decimal point to your right, you start with what? -1, -2, and you move like this. Why for the whole number part, you start with what? 0, 1, 2. So that's, once you get this, your work is half done. All you have to do now is to start applying your prerequisite knowledge to simplify this particular expression. So here we are going to be having 2 multiplied by 5 raised to the power of 1 is 5. 4, I've explained earlier that anything raised to the power of 0 is 1. Let it be x, let it be 1000, let it be Feyi raised to the power of 0. It still gives us 1. Now, this is where the prerequisite knowledge of indices, basic knowledge of indices, is going to be applied. So we have 3 multiplying 5 raised to the power of -1. The law of indices explains to us that when the power of a number is negative, is also the same as taking the reciprocating that number. So instead of having 5 raised to the power of -1, we have what? 1 over 5 raised to the power of 1. We're going to apply that same law to this other side, meaning that instead of having 5 raised to the power of negative 2, we have 1 over 5 raised to the power of 2. The negative is gone by reciprocating 5. It's a law of indices. Now, let's continue our simplification. 2 multiplied by 5, you are left with 10 here. 4 multiplied by 1, you are left with 4 here. Addition is still intact. Now, 3, okay, let's take this. Let's add this step. 5 raised to the power of 1 is 5. So let's leave it that way. 1 multiplied by 5 raised to the power of 2. Remember, 5 raised to the power of 2 is not 2 times 5. Rather, it's 5 times 5, which is 25. So here we are having 10 plus 4. Let's just go ahead and put 14 here. So 3. Converting this, if you can either do this as fraction or you convert it in decimal form. 1 over 5 in decimal is equivalent to 0.2 plus 1 multiplied by 1 over 25 in decimal is equivalent to 0.04. Now we are left with 14 plus 3 times 0.2, that's 0.6 plus 0.04. So adding it together, you have 14 plus, if you take this decimal together, you'll be having 0.64 and giving us 14.64. Hence, our 24.31, which used to be a base 5 number, is the same as 14.64, a base 10 number. If you follow this example very well, you should be able to work with this exercise where you have to convert 111.01, a base 2 number, to base 10. As I said, you have to identify the digits. The whole number part will start from 0, continuing to the left, and you're multiplying it, while the fractional part will start from -1, -2. If you follow this example carefully and calculate and work this, you should arrive at 7.25, a base 10 number. I want you to practice this, and let me see your results in the comment section.